Have you ever looked up at the stars and wondered what secrets those distant lights might hold? While many are stars, a select few are actually our neighboring planets. Neptune, the most remote planet in our solar system, is a mysterious blue world, so far away that sunlight takes more than 4 hours to reach it. Only Voyager 2 has ever visited Neptune up close, back in 1989, uncovering a frigid, stormy giant unlike any other planet. Classified as an ice giant, Neptune isn't quite like Jupiter or Saturn. Its interior is a chilly blend of water, methane, and ammonia, all swirling above a rocky core. The planet's striking blue hue comes from methane gas, and its atmosphere boasts the fastest winds in the solar system, racing at over 200 miles per hour. Massive storms rage across Neptune's surface, some rivaling Earth in size. Yet so much about this distant world remains a mystery. Even with our best telescopes, including Hubble, Neptune has always appeared blurry, like trying to read a sign from across a field. We needed a revolutionary way to peer through the darkness and distance to truly see Neptune. That's where our journey begins. Neptune, the silent ruler of the ice giants, has been keeping a dramatic secret. With cutting-edge technology, we can finally observe Neptune as it really is: restless, energetic, and sometimes fierce. The cosmos is always communicating. Every so often it makes itself heard loud and clear. All it takes is the right instruments to tune in. And now, we finally have them. To see what's hidden, you need a special eye, the James Webb Space Telescope, or JWST. Launched in 2021, JWST orbits 1 million miles from Earth at the cold, dark L2 point, perfect for detecting faint infrared light. Infrared lets us see through cosmic dust, revealing the universe in ways visible light cannot. JWST's massive golden mirror collects this ancient light, allowing us to peer into stellar nurseries, distant galaxies, and the atmospheres of exoplanets. But why turn it toward Neptune? Because JWST's infrared vision can see deeper into Neptune's atmosphere than ever before. It reveals temperature differences, chemical fingerprints, and hidden layers invisible to Hubble or ground telescopes. In August 2025, scientists pointed JWST at Neptune, expecting routine data, maybe clearer rings or storms. Instead, the universe delivered a shock. The data was anything but ordinary. Neptune, the silent blue giant, was showing signs of a fresh, massive wound. Something extraordinary had just happened, and JWST caught it in the act. When Webb's images arrived, scientists expected familiar storms and rings. But in Neptune's southern hemisphere, they saw something unprecedented: a vast, bright smudge glowing intensely in infrared. This hotspot was thousands of miles wide, far warmer than Neptune's usual frigid atmosphere. It was like finding a bonfire in Antarctica. Unlike Neptune's typical dark storms, this feature was brilliantly bright, signaling a recent massive energy release. JWST's sensors also detected unusual chemicals, carbon monoxide and hydrogen cyanide, far more abundant than ever seen before. These weren't the products of normal weather. The evidence pointed to something external energy had been added from outside Neptune. The combination of heat and strange chemistry was a smoking gun. Scientists realized they were witnessing the aftermath of a colossal impact. Neptune had just been struck by something big. How do you connect a hotspot to a giant collision? It's all about the clues. Neptune's upper atmosphere is usually stable and cold. Only a sudden, massive energy release could create such a hotspot. Storms move heat around, but impacts inject new energy, just like the Shoemaker-Levy 9 comet that scarred Jupiter in 1994. Computer models showed that a large object slamming into Neptune would create a thermal plume exactly like what JWST saw. The strange chemicals, carbon monoxide and hydrogen cyanide, are forged when methane and nitrogen are blasted by extreme heat and pressure, just what an impact delivers. These molecules were the cosmic equivalent of gunpowder residue. Over days, scientists watched the hot scar cool and stretch in Neptune's fierce winds, behaving just like an impact plume. By tracking its evolution, they could estimate the energy and size of the impactor. All evidence pointed to one conclusion: a collision had just rocked Neptune. The planet's new scar was a fresh reminder of the solar system's ongoing drama. This was no ordinary storm. It was a cosmic event caught in real time, and it changed everything we thought we knew about Neptune. With the evidence clear, the next question was, what hit Neptune? The solar system is full of debris, but only something big could create such a disturbance. The prime suspect, a comet from the Kuiper Belt, a region beyond Neptune teeming with icy bodies. Comets are rich in ices and travel at incredible speeds, perfect ingredients for the observed heat and chemistry. Asteroids are less likely, as they're rarer in Neptune's neighborhood and lack the right chemical signature. A rogue centaur, an object with an orbit between the giant planets, remains a remote possibility. Neptune's moons are ruled out, their orbits are stable. By analyzing the impact plume's shape and spread, scientists hope to trace the object's path back to its origin. The search is on, not just for what hit Neptune, but where it came from. Each clue brings us closer to understanding the solar system's restless nature. This impact is more than a spectacle. It's a scientific goldmine. The collision dredged up material from deep within Neptune's atmosphere, giving us a rare glimpse below the clouds. By analyzing the glowing plume, scientists can test models of Neptune's composition and structure. Does the material match our theories, or will it force us to rethink how ice giants form? Studying this event also sheds light on the physics of impacts across the solar system. Impacts shaped planets, delivered water and organics, and still pose a threat today. Watching one unfold on Neptune helps us refine our models for Earth and beyond. Every impact from Jupiter to Neptune is a lesson in cosmic evolution and planetary defense. Neptune's misfortune is our opportunity to learn. The universe is a laboratory, and sometimes the experiments are spectacular. We just have to pay attention. Picture the Space Telescope Science Institute in Baltimore. A quiet night, a young scientist processing Neptune's latest images. Suddenly, a massive, bright blotch appears on her screen, so intense it looks like a glitch. She calls her supervisor. They double-check the data. It's real. News spreads fast. Calls, emails, a global video conference. Dozens of scientists stare at the unbelievable image, excitement building. Urgent requests for more web time are approved in hours. The world's most powerful telescope is now focused on Neptune's fresh scar. Every new image reveals more. The hot plume stretches, caught in Neptune's jet stream. Scientists are witnessing planetary weather in action, not just theorizing. This is the thrill of discovery, the culmination of decades of work, all for this moment. For these scientists, it's the discovery of a lifetime. They're the first to witness a major collision on an ice giant. The universe, once again, has surprised us. What comes next? This single event has opened a new era in planetary science. Neptune's scar will fade, but the data will shape research for decades. This impact becomes the benchmark for ice giant collisions, forcing us to update our understanding of the outer solar system. Our solar system isn't static. It's alive, evolving, and sometimes violent. How often do such impacts happen? Are they key to Neptune's mysteries, like its unexpected warmth? JWST has exceeded expectations, revealing a universe more dynamic and beautiful than we imagined. What secrets will it uncover next, on Uranus or the moons of Jupiter and Saturn? Every observation now carries the thrill of discovery. This is why we explore, to be surprised, challenged, and humbled. Neptune's impact is a cosmic message, a reminder that grand discoveries await, even in our own backyard. The universe is vast and wondrous, and we've only just begun to read its story.